Okay, thank you very much. And thanks, Mikko, for laying the background for this talk. We can either improve the performance of the machines, or we can improve the understanding of how people perform the operations and thereby cut the costs. So in this talk, I will be more talking about people than machines, but both and their interaction are very important. We have been doing research using eye tracking for maybe nearly 12 years. We have been working with quite big companies doing recordings in Microsoft Research at Lufthansa, also with some university academic partners and the local partners. And our background comes more, at the moment, more from the medical side, but as you will see, there are very clear links, and one of the clear links is actually eye-hand coordination. I don't have a plumber here, but obviously eye-hand coordination is very, very important in everyday skills, as we talked just in the discussion previously. So when you do work like this, the way that you are looking at the problem, the way how you plan, this all is driven by how you look at the things. And the more skilled you are, the more proactivity engaged there is. So you will be looking ahead of the task, ahead from the tools that you are currently working. And this is a sign of an expert. If you put a new driver to the car, you will see that they are not looking ahead. They are looking at what is just in front of them. There is no good planning, and the gaze is following the planning. So the same thing goes when you start to operate machines, and when, for instance, you have an indirect view on the task. Again, over here, you are, if you would be a skilled surgeon, you will be looking ahead of what you are currently doing, and thereby the gaze plays a very important role in the skilled operation. So, for instance, we may learn that experts and novices have different strategies when they attend to important information. And for instance, in this case, the experts are looking at what is relevant, and they are looking ahead of it. We've been doing some research also in laparoscopy, and maybe this chart is at the beginning very difficult to read, but basically these two lines are telling us that the gaze is preceding the tool and is always there ahead and well used in planning. So if you forget any other thing from this talk, well, remember that the most important skills in machine operations are the motor skills and eye-hand coordination. All right, the forest machine operator work is very joystick intensive. This is a shot from the simulator. There are joysticks in both hands, and they are not only used for moving or operating the head of the forward and backward, but there are also buttons. So actually there is at the moment quite many movements that the skilled operator has to conduct. And in here, really the visual input and the visual scanning is very important and plays an important role. When Mikko was talking about the 40% variance, I managed in the meanwhile to find also academic reference, though it's from 2004, but already there's been some research showing that even operating the same machines, but the different operator, there can be very big difference in productivity. So even if we fix the machine, even if we improve the machine, there will always be the potential to improve the human performance and thereby increase productivity. Let me briefly introduce the principles of eye tracking, the tool that we use for understanding the eye-hand coordination of the forest machine operators. The current eye trackers are using infrared emitters. They are pointing light, invisible light to the eye, and then there is machine vision used to detect the center of the pupil and the infrared light reflection. And when we know these 2 points, we can already track the direction of somebody's gaze. The modern eye trackers are very fast and very accurate, but they are still the kind of lab-grade devices, and they are also very expensive. I will show you in a while, and that's why there's many people who are actually building their custom-based eye trackers. They work on the same principles, but maybe are not as costly. So, for instance, in our lab we have one of these eye trackers, and this piece may cost about 30,000 euros. So it's not really ready to be deployed to your living room, but if there are potentials, if people can start using that information, the price will definitely drop down. And hopefully it will be very cheap and it will be integrated in everywhere we go. This is the type of eye tracker we have used in the Forest machines. So there is also a wearable version. Price is about the same. Accuracy not that good as when the device is fixed in front of an operator, because it wiggles on the eyes, and there are some other troubles. But anyway, hopefully these devices at someday will go down with their price. This is kind of information you can get typically from an eye tracker. You may get understanding when somebody is searching for an information, what he's been reading, what he's been attending to, and in which order. And typically, the more important that information is, the longer the person would stay there. Okay, let's look at how eye tracking could be used in forest machines. The title originally was about harvesters, though at the end we did the study in forwarder context. So, if we would have an eye tracker in the cockpit, and there would be a really robust gaze tracking, we could maybe be able to control the machine using the gaze. You could send signals just by looking at things, and maybe you could be controlling certain operations. But we would be also using it in a kind of passive way. So we could maybe do fatigue detection, workload detection. We could understand when the driver is not focused. This all would be available if we would have eye tracking involved or incorporated into the cockpits. If we move away from the machines, then this is a very strong tool, and it's one of the things that we are actually focusing in here for training. So if we integrate an eye tracker to a simulator, that simulator can become aware of where the student or the operator is looking at, and can modify the information based on the skills that can be estimated from the gaze. We can also teach expert strategies so that the new operators, the new students, can start to behave like the experts, and thereby their performance and their learning is improved, and their learning is shortened. This is one of the examples, again, from medical domain, where radiologists are looking for pulmonary nodules. This is a gaze display. This is a replay, a visualization of where the expert is looking, and then the students are adopting their strategies just by being aware where to look. So we could have used maybe the same information also in the forest machine simulators. For instance, here also the fracture has been highlighted, and then the patterns of the new radiologists have changed because they were suddenly aware where to properly focus. So in our case, we look at the forwarders. We were tracking gaze in two environments, in the simulator and also in the real machine. The task was so that we set up the logs around the machine, and also in the simulator in this pattern on one side and on the other side. And the task was to load the logs onto the machine and then unload it. And we used the wearable eye tracker, and we rigged the whole environment. There's been quite a lot of cameras put around, and I'm therefore able to show you this great video, which has these all streams aligned. And so what we see here, this is the view from the head-mounted camera on the tracker. This is some advanced computer vision that we use to detect the grubber or the head of the grubber. And the violet point that is moving here abruptly, that's the point of the gaze of the operator. And very soon I will show you some of the snaps that are very important in here. But what you can see, I hope, in the video is that the gaze is really kind of pulling the head, the grabber, and so it's really this has been skilled driver. This has been one of the lecturers in Baltimore, and you can see that the gaze is really proactive in this case. And there are certain moments that might not even be visible for untrained eye, but there are very brief proactive fixations to where the operator is looking at, and then at certain moments he's checking things that are very relevant to the task, and that we will be later on discussing with the teachers of how to transfer that knowledge to the training of the students. And then also we aligned the data with the other stream, so we put one of the cameras on the boom, so we may precisely see what's been going on. This is mounted on the top of the cabin, and this is one of us walking around and taking pictures or taking videos from what has been going on. Okay, in here, this is the beginning of the task. The gaze is located at the grabber, at the head of the grabber, and then I just made a few shots. They are not really exhaustive in terms of going through the whole cycle, but we may see that at certain points the gaze is going forward and backward between the intended target and the tip or the head of the grabber. So basically these all are indicating, for instance, here the gaze is at the top of the log to make sure that this is properly balanced. Here the gaze is located at the extension of the boom to make sure that the boom is being retracted. Here you see again the gaze is not on the tip, but it's somewhere here because the operator is already ahead planning what to do, and so on. There's a lot of this important information, and we will be able to compare that to how students perform. This is another visualization of the data that we can get. The red lines here are the points where the machine grabbed the logs, and then here is visualize the distance between where the person's been looking and the tip of the grabber, and then we can see that at certain points, and these are very nicely synchronized all the time, there is very important visual behavior that we can analyze. Very similar thing we have done in the simulator. I don't have the data now. It would require a little more time because we just did the recordings a week ago. So there's been also some challenges. One of those is to make sure that these devices perform well outside. We have been recording the data in a very nice autumn day. It has been very shady and everything was yellow, and this is also causing some problems to the computer vision that we are using. There is, of course, the best results we would get if we would get access to the real machine data. This particular machine is logging everything that is happening. There is potential for really full automation combined with the gaze. So we will see into that in the future. And then one of the troubles is accurate calibration, because as the head is moving, the glasses, the eye tracking glasses, are also a little moving on the head. We are looking to deal with certain types of challenges. For instance, over here, this is a kind of a borrow to the multispectral imaging folks. We are planning to use multispectral cameras to even improve the stability of the gaze tracking. Okay. This is maybe just okay. This is stacked on the last slide. All right. Well, I would leave you with this message. The proactive gaze is really important for safe and efficient machines and their operations, but so is research about it. So I would invite everybody who is interested in joining us in these efforts to talk to us after this session or later, and we can hopefully make something very important. Thank you for your attention.
Thank you, Roman. And now the question. Well, then I make some questions. How expensive is the system that you track the eye? You told about 30,000 euros. Will the price come down so that that could be, for example, a standard device in every vehicle in the future?
Yeah, well, this is a lab-grade device, so it's sold to the laboratories, and that's why the price. I think that with widespread, the price will definitely decrease. The bill of materials for this kind of devices is not that big as 30,000, definitely.
Would it be cheaper to use some kind of augmented reality, like the extra glasses they have in the demo?
There's no really alternative to proper eye tracking, so you need to use gaze tracking to be really sure what the persons are doing. The type of behaviors I was showing there, they happen on a millisecond scale, so that's what is going on. The operators themselves are not even aware of the scanning behaviors they do, so that's happening that fast.
Yeah, that's when it comes to eye tracking, but I was referring to other type of system. Would it be beneficial for a driver to use augmented reality glasses and get some extra information? Not eye tracking, but something else. Have you any plans or ideas of that?
I believe we are not the only ones who are considering of maybe moving in with the VR or augmented reality technology. So for sure, these systems are coming. Relative to the whole machine price, this is still just a fraction.
Yeah. How about in the future? Will it be possible someday to get rid of the traditional controls completely, and so that you could do everything just by gazing at things and perhaps blinking your eye, grab that?
I don't think so. But certainly, what is happening is that the driver does not need to sit in the cabin.
Yeah. So he will be in the office or in the classroom or
maybe.
Yeah. Okay. Everything is remote controlled.
Yeah.
Yeah. Oh, that's good. Any other questions?